Here we are trying to solve an equation involving rational expressions. So the first thing we're going to need to do is factor each denominator. In this first denominator, we have a GCF of 2, and that leaves a minus 1. In the second denominator, we have a GCF of 3, and that leaves with a plus 1. In this last denominator, we have a GCF of 18, and that leaves a squared minus 1. Well, that could be factored further. That's a difference of squares. So that's a plus 1 times a minus 1. Let's cross off this so we don't get confused. And the other thing I want to point out is that we have a minus here, so be careful. So our LCD. Well, let's look at the numerical factors of each denominator. We have 2, we have 3, and we have 18. What's the smallest number that all three divide evenly into? Well, they all divide evenly into 18. Now, we need a factor of a minus 1. We need a factor of a plus 1. And looking at the last denominator, we need a factor of a plus 1, but it's there. We need a factor of a minus 1, but it's there. Now we're ready to multiply every term by the LCD. And this one's going to get big, so I'm going to try to write a little smaller. So we have a over 2 times a minus 1. Notice I used the factored form of the denominator. Now we're going to multiply by the LCD. I'm going to put it over 1 since I'm multiplying by a fraction. Minus 2 over 3 times a plus 1 times the LCD. And again, I'm going to put it over 1. Equals, and on the other side we have 8a squared minus 3a plus 13 over, and the factored form of that denominator is 18 times a plus 1 times a minus 1. Of course, we're multiplying by the LCD. Now we're ready to cancel common factors. Looking at this first term, we have 2 in this denominator, and 2 goes into 18 in this numerator 9 times. We have a minus 1 here, and a minus 1 here. So what are we left with? Well, the denominators, we're left with 1 times 1. In the numerators, we're left with a times 9 times a plus 1. So we have 9a times a plus 1. I'm going to write that down here. Minus. Take that extra step when you're dealing with subtraction. Okay, 3 goes into 3 once. 3 goes into 18 6 times. Then we have a plus 1, a plus 1. So what are we left with? Well, we're left with minus 2 times 6, which is 12, times a minus 1. In this last term, we can cancel the 18s, the a plus 1s, and the a minus 1s. So we're just left with the numerator, times 1, which is 8a squared minus 3a plus 13. Let's clean up the left side. We have 9, a times a is a squared, plus 9a, and then we have minus 12a. Careful, negative 12 times negative 1 is positive 12. Okay, and now we have like terms here. We have 9a squared minus 3a plus 12 equals 8a squared minus 3a plus 13. Let me clean up here a little. Okay, so now we're ready to evaluate our equation. What type of equation do we have so we can determine what direction we should go in? Well, we see a squared there, so we know that it's quadratic. So let's get 0 on one side then. So we want to subtract 8a squared, add 3a, and subtract 13. That'll give us the 0 we want on the right. Of course, we need to do the same on the left. So we have minus 8a squared plus 3a minus 13. So we're left with a squared plus nothing minus 1 equals 0. So we factor, and we have the difference of squares. Let's set each factor equal to 0. So we get a plus 1 equals 0, and a minus 1 equals 0. Solving for a, we get a equals negative 1, and we get a equals positive 1. I did skip a step there. All right, negative 1. Let's go to the LCD. If I plug negative 1 in here, well, there's no variable there. What about here? If I plug in negative 1, will I get 0? Negative 1 minus 1. No, that's negative 2. What about here? If I plug negative 1 in for a, I get negative 1 plus 1. Well, that's no good. I get 0. If it makes any factor of the LCD equal to 0, then it makes a denominator equal to 0. So a cannot equal negative 1. So that solution's no good. Let's go back and look at 1. If I plug in 1, and of course we're not going to plug in 1 in that first factor. If I plug in 1 here, I get 1 minus 1. Well, that's 0. I don't even have to check the next factor because it makes one factor equal to 0. That's no good. So this problem has no solutions.